So, um, I'd like to start. Feel free to eat, and definitely feel free to like interrupt me with any questions, especially when I start, coding, because my goal is for this to be. I'm aiming for this to be pretty beginner friendly, but I also want to talk about, serious, interesting stuff. But I guess, this is an intro to Rust. This is an ACM event. Can everyone see this all right? I hope so. It's pretty simple right now. Anyway, um, yeah, so I'm Samuel Skeen. I'm a second year master's student in CS, did my undergrad here too. I focused on System Z programming, that's lower level stuff, a fair amount of reading assembly, but what's more important is just writing the sort of stuff that you would write in C, writing bits of a kernel, writing a compiler in 473, which is a great class. I took that a few semesters ago. And then, over the summer, something crazy happened. I got a full-time offer at Apple. I haven't started that yet. That'll be after this semester. And yeah, that's a bit of a lie. They're Apple. They don't want me to write in Rust, but they want me to write in Swift. It's Apple's culture is whatever. But what's very true is that if I didn't know Rust, I wouldn't have gotten the job unless I had somehow learned basically what I think to be the core stuff that I actually learned when I was learning Rust some other way. And another thing I'll say is that I don't know how much this comes up I don't know how much this matters when writing, say, apps in Swift. But if you want to do lower level stuff in Swift, or if you just are interested in how the languages work, Rust and Swift are kind of sister languages. There's been a lot of cross-pollination between their development. They came around at the same time, and they're trying to solve the same problems in similar-ish ways. Yeah, that's complete bullshit. I wish Apple was doing a better job of making my watch a remote. Anyway, we've got some common sense categories that you've probably heard of. You've got nicer languages. I basically put everything I've heard of, that I think fits this category.
I think Go should also go in the fast wiggle.
Yeah, so that's why I put the question mark there. Does anyone have an idea what the hell's going
If you
on?
cover the sensor, it'll turn off.
Yeah, don't block the line of sight.
Oh, so don't gesture the way that I want to.
Yeah, just
Okay.
gesture from the side.
Yeah, understood. So does anyone have an idea what all of these things have in common, but C and C++ don't have, that might be associated with their performance? Anyone can say anything if you have an idea. Yeah, sure. Max.
It just happened. I don't know. It's not quite GCC when you have to put a bunch of flags in to make sure that things work, but you can just like straight up and have it in one line.
True. Okay.
Garbage collectors.
Garbage collectors. Yes. So when it comes to the performance bit, all these languages have garbage collectors. That's not like immediately your language is slow or anything like that, but there's a limit on how fast your language can get, and more importantly, a limit on what kind of code it's appropriate for if it's got a garbage collector. It's not so much about raw speed. It's actually about, can you predict how fast this thing is going to be, right? At the very low level, for the operations that run tons of times like a second, as you're just using your computer or as a server is operating or something like that. At the low level, we don't just care about it being fast, we care about knowing how fast it is. The thing about garbage collectors, at least as they're implemented in almost all of these languages, is sometimes they take longer, sometimes they take shorter, and we don't know when they're gonna run. So that's just kind of means these are not all right for lots of jobs. So C and C++, those are good for a lot of things, including like games and kernel programming and lower level stuff in an operating system that isn't in the operating system. That isn't in the kernel. If you don't know the distinction between the kernel and the rest, that's fine. But the kernel is a very core part that is almost always written in C, in my experience. But there's some attempt to write it in somewhat newer languages. Linux has a little bit of Rust in it. Linux is who here has heard of Linux? Who here hasn't heard of Linux? Okay. Yeah, so Linux is a free operating system. It's like an equivalent of Mac OS or Windows in broad strokes. And free as in it's developed out in the open and it's freely available and it's free to contribute to too. You know, you don't have to work for anywhere to contribute. And a bit of it's written in Rust, and there are good reasons. So Rust is exciting because it tries to unify this. It tries to be both nice and fast. And I put the word fickle here because I think the particular way in which C and C++ are not nice is the compiler is a bit of a trickster. It sort of feels like, right? You write your code and then you make a mistake. Like your index is too large for your array. Your array only has 5 things in it, and you say, "Give me the 6th thing," right? And then your code might blow up. I'm sure you've all seen, if you've written some C or C++ for a bit with arrays, I'm sure you've seen a seg fault. But it might not, and that's the worst thing because then we don't know what it's doing. It's sort of unpredictable. That's the sort of thing that makes your boss and anyone who cares about the success of your product quite antsy because we might not catch the problem. And that's particularly important when the problem might only be like triggered if someone's trying to exploit your program, but that's a different topic. Anyway, how does it do this? How does it try to marry these things? Well, I think the bad news is that there is a giant trade-off. The programmer has to try harder because the programmer has to care about things that most of these other languages, even C and C++, to some extent hide from you. C and C++, if you're trying to write good C and C++, you need to understand this or have an equivalent understanding. The stuff that you need for Rust. But Rust makes you deal with it because otherwise your code won't compile. Now, I think this is great. A lot of people think this is great because the best bug is one that never happens when your program's running. The best bug is the one that you found before you could run your program. But another thing is, we have this trade-off, and it gets better as you learn the language. But because Rust is so focused on saving you from yourself, not being a trickster, being nice, doing the right thing, and telling you if you're doing the wrong thing at compile time, it actually ends up safer, and I won't get too clear on that, but it ends up being, saving you from yourself, I guess, in more situations than almost all of these languages on the left, right? For instance, if you're writing concurrent code, that's a lot nicer in Rust frequently because Rust will actually stop you from writing certain kinds of errors, certain kinds of, like if 2 threads are trying to do the same thing and does everyone know what a thread is roughly? Yeah. Does anyone not know what a thread is? It's fine. Okay, so a thread is like one part of your program as it's running that is like running instruction after instruction. You can have multiple of those, and that can be a way to speed up your program. But if you have multiple of those and they're not written well, they can step on each other's toes and create all sorts of weird problems. It's like, 2 people running into each other as they're going through the hall, right? That sort of thing can happen, but on your computer, which means it's happening at like nanosecond scale. And it also is kind of a disastrous bug in particular because it only happens sometimes. Almost all of those concurrency-related bugs only happen sometimes. So that's where it's a big benefit to catch the possibility of them at compile time. Because then you're not talking about running your code. You're not talking about one run of your code. You're talking about, can my program ever produce this bad result, right? The compiler will prevent that bad result from being possible. So you just don't have to worry about that issue a lot of the time in Rust. There's this concept in Rust, one of the things that it gives you that all those nice languages also have, but C and C++ don't, is memory safety. It's a weird term, and I tried to define it nicely, but I'll do so with this definition, which I just made up, but it fits with what I've definitely been taught, and with some examples. So I think when you're writing a program, who here has written a program using arrays? Who here has written a program using pointers in C or C++ or C# or, yeah, okay. Everyone, okay. It's easy to screw up, right? And there are lots of things that you can do with it that if you really think about like what I could possibly mean by writing this code, it's like, no, I didn't mean to do that. Like I never meant to dereference null because I know that's bad, right? That means you're interacting with memory in a silly way. Or it could be, I freed something and then I interact with it, right? I dereference that pointer. You never mean to do that. That's, silly. Equally, actually accessing out of bounds in an array is something you never mean to do. It might be that you want, that to be an error condition. It might be that you want your program to crash when it happens to access out of bounds. But in C and C++, that's not what happens. What happens is, I don't know, the compiler in the language says it's undefined behavior. I'm being kind of vague, but I'll get to more concrete stuff because now we're doing demos. To start up a new project in Rust, you typically use this command cargo. It's a lot like npm if you've ever used that. It's sort of your first port of call for actually running, compiling your code, stuff like that, and for installing dependencies, which I don't think I'll be doing very much of at all here. So, can everyone see the text all right? Okay. Honestly, we're not going to be writing a lot of code because even simple code gets tricky. So this is a basic Rust program. It's a hello world. It's auto-generated by that tool, so that's nice. It does what you'd expect. This is the tooling. This is what my program actually did. And then this is something I set up, but it's not important for now. So, let me think. Yeah, so I've been talking about how Rust gives you memory safety. It definitely does, but there is an escape hatch, as there often is. There's a way to break out of that and then be unsafe. But first, I'll be mostly focusing on the safe stuff. The kind of Rust code that you can write with all the nice guarantees I've been talking about. I defined a variable x, and it's an integer. It stores the value 5 initially, and then I won't get too much into the syntax of this print line statement because I don't think it's all that interesting. It's interesting to me because I love Rust, but not for this. But I can make it print out after hello world. You might notice something missing from this line compared to C and C++. Does anyone know, like, if I were writing, yeah.
Assigning its type, so int.
Yeah, so I didn't say int. I didn't say anything that means the type. This is funny. I'm not prepared. I need to install my Rust extension. What is it called? Rust Analyzer. What are you talking about?
What editor is this?
This is Zed.
I don't know what's there.
Yeah, it's very much like VS Code. It is written in Rust. I don't know what's going on here. This kind of sucks. I'm going to debug this for like 5 seconds.
I just googled Rust language on Google and it says like the first top comment is like Rust sucks.
Oh yeah. So
Reddit.
people are real passionate about Rust in both directions, right? And I don't even know how to get my browser to show up. Okay.
Administrators are mostly like C programmers were saying that not being memory is a skill issue. But
Yeah.
80% of vulnerabilities are like vulnerabilities.
Yes. So
If there's a skill issue, it's you.
yeah. So you didn't. I don't know. I think you probably didn't hear that, but yeah. So lots of C programmers say, well, C makes sense to me, and C doesn't have this demand on my attention and this weirdness of Rust. So I'll just stick with C. I think that's where the root of it is, honestly. Some of them say that, like, if you're screwing up in all the ways that I named in C, it's like your fault, and those are easy errors to avoid or something, or the benefit of sometimes being able to break those rules is better. Something I didn't get into that I want to just briefly say is like all these rules that Rust is enforcing, it does so conservatively, which means that I don't know if I should say it that way, that it is conservative in what programs it allows you to compile. That's what I'll say. It enforces these rules by making sure that, out of bounds can't happen. Use after free can't happen. If you're writing safe Rust, what I'll be writing here, which is most of the Rust that you should write, it ensures that they will never happen, but that means that if you're following those rules, there are some programs you can't write. That's why there's the escape hatch. Usually, that escape hatch of unsafe code can be sort of put into one bit of your code base so that you only care about it when you're looking at that code, and you can test the hell out of that code and then be 99% certain, or if you want 100% certain because you've mathematically proven it, but no one has time for that, that doesn't have any problems, right? And then the rest of your code, all the stuff that you think of as the interesting thing your app does, all the algorithms, most of them at least, can be outside of that. And they can depend on the correctness of the unsafe code that you're writing to be to ensure that they are safe and not screwing up, and don't have those issues. So the point is this conservativeness in Rust is, I think, what pisses a lot of people off, because it means that there's this extra thing that if you're writing C and C++, you just don't have to worry about, but you do in Rust. I'm going to try to get this to work. How do I? Z Rust, it available natively. Oh, that's why there's no extension. I just don't know what I'm doing. Yeah, this is silly. Okay, I'm downloading VS Code because I know how to get it to work the way that I want it to work. I've been using this for a while, but
Sam,
Yeah.
do you know how they say that it's very easy to shoot yourself in the foot with C,
Yes.
and with C++, it's like you can blow off an entire limb?
Yeah.
How would you put Rust into that analogy?
I would say that if you're writing Rust well at all, and I think that that's actually not a huge hurdle to clear. If you're writing Rust the way that it's meant to be written with safety, I think it's way harder to shoot yourself in the foot than with either C or C++. If you're writing unsafe Rust, which it's always a judgment call, or to an extent, it's a judgment call in many situations where you really do care about performance, whether you want to go unsafe or not. There are ways in which it is harder to shoot yourself in the foot, and there are important ways in which it is easier. I agree with most of the decisions that Rust has taken, but I think that, by and large, a lot harder to shoot yourself in the foot.
You're at a firing range with someone who has 20 years of experience helping you aim your shot,
That's
getting
very
you a
smart.
kiss on the cheek before you pull the trigger.
Very nice.
I didn't follow that.
The analogy of shooting yourself in the foot, you have to
Yeah.
shoot your target, right? That's
Yes, no, the goal, I think, in this analogy is to shoot your target. Okay, now it decides to work. This is what I was trying to show you. What?
You just had to threaten it a little bit. To say
Yeah.
what
It really was unhappy with me installing VS Code. So now it's working. Anyway, yeah. So this colon is actually a somewhat standard way in some languages to indicate the variable on the left has this type that we wrote on the right. If you're not familiar with it, that's totally fine. Not a ton of the most popular languages do it, but the rest does. And you might see that it's an I32, not an int, or an integer. I32 is how Rust writes what we usually mean when we write int in C. It's a 32-bit integer. It's 4 bytes wide. Yeah. But Rust has figured this out, and it's showing me this thing when I hovered over correctly and all that. And it's showing me some other stuff that I'm not getting into right now, but it's showing me this thing. It knows this at compile time, right? This isn't a dynamically typed language, so I could not do something like x equals hi. I hope the message that I end up getting is, I'm not getting an error. Okay, well, we'll get an error when we'll get an error when we save it. I'm silly. Yeah, okay. expected integer found, and this is one of the ways that Rust talks about strings. I'm not sure I'll get to that. But yeah, so you can't do that. But this code seems reasonable, but my editor doesn't like it. Does anyone have any theories as to why this might be? And if you don't, that's fine. Anyone else? Sorry. Anyone newer to Rust? Have any theories as to why I can't assign 6 to x? Okay, sure.
Is it like the first instance like makes it static to the value?
The first assignment makes it static is what you're saying to the value?
Type, and it makes it static.
Yes. By default, you can't modify variables in Rust. It's actually kind of tricky to think about when you get into it. In this case, it's very clear what modifying a variable is. It's just assigning to it. That's the way you modify integers, right? In other cases, it's a little bit trickier. But thankfully, in almost all these cases, if I just have a variable and I want to modify it, I can have declared it with this mute keyword standing for mutable, meaning I can change it.
This works. Look at the compiler error because it will tell you exactly what you did.
Yes.
That's one of the great things about it.
No, that's true. One of the things everyone loves to talk about with Rust is the compiler errors. It feels like this is a compiler from the 21st century, and like the C and C++ compilers, especially GCC, don't feel like that so much. It's like, I don't know, moving from Facebook to Instagram or whatever. If you like Instagram, I don't know. It's just nicer because it's just telling me. It's like, dude, you can't do this, right? This is the problem. It's telling me what I did wrong. What's even nicer is that if I tried just a little bit harder, it would also tell me, how to fix it. Certain errors are so common in Rust that it'll literally tell you, hey, dude, just put this character here, and then you're good. Anyway, this works. It does the expected thing. This is just a warning because it's thinking, hey, I can tell you're never reading 5 from X. This is some weird code. So I'm going to look at my presenter's notes here. Yeah, okay, lifetimes. Lifetimes are crazy. Okay, who here has some familiarity with C++? Okay, when you're writing like a vector, a growing array in C++ or in C, if you have any familiarity with that, I've been talking about dynamic memory allocation a little bit, right? That's the hard part, right? Almost certainly you're going to end up writing some code that runs when you create this array that can grow. And that's going to allocate something. And then you're going to write some other code that's going to run when you no longer need this array, that's going to deallocate it because it's going to free up that memory for use by other things in the system. Other things in your program. No, in the system. And that's some tricky code to write. In C++, we have destructors. Destructors are real nice because they're sort of a pattern where when you're writing a type, like a class vector, I'm just gonna, oh god, pseudo C++ code up here, right? Class vector, and it's like got a int array of, an int pointer in it, and then we have some constructor that we call vector, and we wrote the implementation in there. Then we have some destructor, and that's where we write some code that almost certainly says like free array, right? My editor's not so happy with this. It's not the right language. Basically, the reason I'm referencing this and writing it is because Rust does the same thing. Almost all the types in the standard library have destructors. All the ones that need them. All the ones that do dynamic memory allocation. But I think the principle of what a destructor does is it's like, okay, this is a pattern, right? You create a thing, you allocate memory, you get rid of the thing, you no longer need that memory, right? Rust takes those sorts of patterns to the extreme, really supports them. That's basic stuff. It would be nice if our language supported them. And made it so that it's not just, I happen to be writing the correct series of instructions that needs to happen for this operation, this creation of something and then destruction of something. It really supports the pattern better than that. I'm going to get into something more complicated, which I'm actually not going to show the destructor example in Rust right now, Whoops. But you know, in C and C++, we have this notion of pointers, right? In Rust, we have something very similar. This looks like I'm taking a reference to x, taking the address of x and putting it into a different variable. And the type is written a little differently. We don't write the type with star. The way you want to think of these types is that it's written with the operator you use to create it, this ampersand, followed by the type name. The ampersand is still the address of operator, right? But what it creates actually is something of the type reference to integer. This is something that we can treat like reference to an integer. We can or treat like a pointer to an integer. The syntax is like pointers. It's not like references in C++. So you have to be explicit. You know, I want to modify the thing behind x, not x. The thing behind pointer to x, not pointer to x itself. I don't want to change what it points to. I want to change the thing that's already there. So I can do something like change it to 10, and then when I print out x, right, this should be should print out 10, right? Is everyone sort of following? Yeah.
Does X still have to be mutable for this or not?
Right. X does have to be mutable, which is lovely because I haven't told you the full story. But what's not so lovely maybe is that we can't do this. This code doesn't work. Okay, we can't assign to star pointer to x, which is behind an ampersand reference. Sometimes the compiler's a little bit cryptic, but I guarantee that this can end up making sense. Ampersand is only one kind of reference. The other kind that we really want here is a mutable reference, which is different from pointer to x being mutable. I can do these two things, and this code is different from this code, is different from this code. It's also different from this code. This code still doesn't work. I made pointer to x mutable. That means if I had like y over here, and then I wanted to say pointer to x, you know, actually I want it to equal the reference to y, so it's referring to y. You know, that's what mutable lets me do. If I get rid of it, then I get an error here. I see that the squiggles are pretty hard to see. I hope everyone can see them enough. But what we care about is actually the mutability of the reference itself. It's a different type. What I'm trying to do here is just change change the value of the pointer. What if I want to change the thing behind it? I can't do that by default. I have to make it a mutable reference. And now I can't actually put an immutable reference in it, but we'll get rid of that. We'll go back here. Does anyone have any questions, by the way? I realize that this is a little freaky, right? This is not a thing that normal languages do, okay? I want to emphasize that, I should have said this earlier, almost all of the freakiness, the compiler errors you've never freaking seen before, never fucking seen before, are in the type system, right? It'll be some things of the wrong type. But that doesn't make it so weird. It's just that is the way to think of it. The way to think of it is this type is fundamentally a way to think of the sorts of things I can do with values like this. You think of types as like, oh, there's an integer, there's a string. Those are like real things in my head. You know, a string, that's like the sort of thing that I could write on paper or tell to my friend or whatever, right? An integer, it's a number. It can count things. A more useful way of thinking about it mathematically, and for this purpose, is an integer is a thing that I can add other integers to. And the result of that is another integer. And there are only certain things that I can do with that, right? You might get an overflow. Has anyone heard of an integer overflow? The notion that there's some value you can't go past, right? Rust also has some tricks to try to make those harder to do as well. I don't think I'll get into them, but like all of this, it has to do with types. You can imagine a type where the result of adding 1 to that largest integer is not a value, it's an error. And that is, the way you can do this. But it gets freakier, but the key thing is a type is like the set of things that you can do with values of this kind, of this type. So yeah, we can assign through here. I'll get rid of y because it's not useful here. And then, okay, it's gonna compile, right? Yeah.
Is there ever a use case for line 3 where we would not put mute on
Yes.
ampersand text?
Right. So I think a lot of people very justifiably, they think about pointers and they think about the freaky things you can do with them, because when they learned about pointers, they were scared, and they were right to be scared because they're tricky, right? I don't know about right to be scared. They were right to care about the little things that can go wrong, right? And the freakiest thing that pointers can do is that they can reference other things in your code, right? I normally I'm like, I have this integer, like that's a physical thing in my head or something, right? And to modify it, I use the name that I gave it, right? But then I'm modifying it through a pointer, and that's just harder to think about. It's also harder to think about even once you know about it, right? It's harder code to write. It's harder code to understand. And that's not just because it's a pointer and not a reference. That's not just because it's in C. It's because that code is complicated, right? Where I'm going with this is the freakiest thing you can do with a pointer is you can modify the thing behind it, right? You can do this, star pointer to X. There are lots of things where you don't need to do that. Many use cases. And the main intuition I want to give you is this way we can have multiple references to the same thing without copying them, right? We can have, if it's a bigger thing, if it wasn't an integer, it was a struct, or it was a vector of a bunch of things, right? I can have multiple references to the inside of that vector in multiple places. I don't have to copy the whole thing every time. That's a big reason people use pointers in C and C++. And what's beautiful, I think this might be kind of intuitive or not, but what's beautiful is if you have a bunch of references to things and you can't modify through any of them, you can't modify the thing they refer to through any of them, you can write code following that rule exactly as though every bit of that code has its own copy. I think that's wild.
Like its own process.
Kind of. Its own copy of that variable, right? It's like, say I've got hi here, right? The string. Let's say, no, it's still pointer to X. Let's say I have this, oh yeah, I love that. I don't have to change anything. This is there's some fanciness here. This might help me later on. And this is, Rust is great. There are 3 string types. I don't know how far I'll get into that. But is freaky. We've got, okay. Got to do this. Okay. Yeah, so we can still do this. We can still, modify. Actually, we have to do it a little bit differently, but we can do like, what do I want to do? We can add the character H to it, right? So or we can add the character space, and then, there are better ways of doing this that I can't quite remember right now. You can add more characters than one at a time. But now we can print like X after having done all this, and I'm pretty sure it'll be a compiler error. Oh, that's lovely. Oh, no, okay. Okay. Oh, right. No, that's what I should be doing anyway. I should be adding more characters. This is the method you use to do that. And what's important to note here is that, yeah, both of these mutes need to be here. If I get rid of this one, this becomes invalid. You can't have a mutable reference to something that can't itself be modified. If I get rid of this one, now I can't call this method because it would modify the underlying thing. This message is talking in terms that I'd love to get into at some point, but not right now. But the key of it is that what we're trying to do here is something that only makes sense if we can modify that underlying data. But the reason I did all of this is if instead of pushing the string, I wanted to print something here, and then I had some other function that could be like arbitrarily far away in my code. In fact, there's going to be some syntax you haven't seen, but this is a global variable in Rust is actually not too bad. I think I do have to write its type, which is funny. But I'll make x a global variable with the keyword static. You're probably familiar. If you're familiar with static, it means something different from global. That doesn't really apply in Rust, and I'd love to get into that at any other time. But we have this pointer to x, this reference to x. Oh God. Okay. I'm not getting into that, but here we have a string x. I had to use one of the three string types here for reasons. But I can print x here, and it works. And then I can call hello, and I can have hello print something a little bit different, like x was, and then put the value of x in there. And this obviously works in C and C++, right? We have a global, we can print it from both of our functions. What's nice about this is that because none of these things can modify x, there's no worry about the thing that is why everyone tells you don't use globals in like 111 or 141. Probably by 141 they're saying, globals are nice, they're simple, your whole program can talk about the same thing, but don't use them, because you get into this situation where I'm calling this function hello, and its name is not great, right? Maybe it does something kind of complicated. In the end, it touches this global, and maybe it modifies it sometimes, and maybe that was a great idea when it was written, but now it's a bad idea because it changed x, right? And now later, I'm going to look at x, or I'm going to call some other function that looks at x, and it changed out from under me. It's like, who reorganized my kitchen, right? Who moved this? I wanted it to be a certain thing. I was reading the code line by line because I thought that's how you understand the program, right? And I wasn't jumping through every function because I thought they did what they were supposed to do. By disallowing you from modifying x here, Rust is doing a nice thing. But you might think, couldn't we just make x mutable, right? Then everyone would be able to change it. Let's try. Let's get an interesting error. Use of mutable static is unsafe and requires unsafe block. I'm glad I introduced unsafe because I hope this means a little bit to you. This is a bad idea, I think, in general, what Rust is preventing us from doing, but that's totally up for debate. Rust does let you share data, have multiple names for it, and modify it. That's a complicateder feature that I won't get into right now or in this event. But the important thing is that this saves us from that global issue. But that means that when I'm looking at code that works like this, that looks like this, I can rely on the fact that x has never changed. I can rely on the fact that x has never changed, which is nice, because x could be pretty long, be a lorem ipsum sort of thing, right? The entirety of Wikipedia or something, and it only exists in my process once, and I know that that's okay, and my program's doing roughly the right thing with it. Okay. I was going to talk about lifetimes. I'm off topic. Yeah, so these lifetime things, if you've heard of Rust, you may have heard of them. If you haven't, that's fine. Get back to where we were before. Okay. Quick show of hands. In C or C++, who's seen code that looks a little bit like, we're printing inside a block within our function? Is this familiar enough to people, or do people have a sense of what this would do? Do you not have a sense of what this would do? Can anyone tell me why I might write code like this in C or C++? It's fine if you can't. Yeah. Scope, okay. Why scope? Why would you want to create this because this creates a new scope. What does that mean and why?
So that you can access the variables that are inside there outside that scope.
You cannot, yes, you cannot access the variables that are inside here outside that scope. So right, he's talking about like here, x exists within here, and now I'm gonna try to take a reference to it, and it's telling me I can't find x in this scope. This is also true in C and C++. Okay. So what's going on here and goes on in C++ is x only exists for this scope. X lives on the stack because it's a local variable. That's true in Rust as it is in C and C++. Because it lives on the stack, there's sort of this concept of a stack here happening whenever I create a new scope. I can create a new scope, and that means that now I'm within that scope and all the scopes it's inside. There's like a hierarchy going on. And it's like when I go into this scope, it's like I'm pushing something onto a stack. And then I pop that area of memory that has this variable in it off when I go through this closing curly brace. That probably isn't actually running. There probably isn't any code doing that. But the important thing is I can have multiple scopes here. I'll say this is like a string or whatever, and these can reuse each other's memory. I don't need space for both of these at once in memory because I'm running this function. Yeah.
Can you name the thing?
Yeah. You can do that in C and C++ too. What's neater, maybe in Rust, but also arguably confusing, but I should show it, is that I can do that here too, right? Like this is weird, right? I just said you can't reassign to a variable after you created it unless it's mute. But I'm not reassigning to it. This is a new variable. It just happens to have the same name. The way this issue is resolved is after this point, I can only refer to this new variable, right? I can't refer to x. We call x shadowed.
You call it what?
We call it shadowed. It's hidden. It's in the shadow of the second variable x.
Is it, you can still access it?
No, we can't access it. It just doesn't exist anymore, and its memory may have been reused. But anyway, so we're doing this. We don't have to spend, memory for both of these because they never exist at once, right? So I might write some code that like does some math that I call myself a Rust programmer. Rust input from the console. One thing I will say about Rust is simple stuff can get quite a bit more complicated. And yeah, I'm just copying because this is some pretty standard code. Simple stuff can get quite a bit more complicated, but this is, if you're familiar with like Python or whatever, it's like taking the input of something. Let's not do this though. Let's do this. Or it's just reading from CN. Yeah, things can get hairy, but what I like about the standard library is it really helps you uphold all those guarantees, and the documentation is brilliant. I don't know if it's something that is the most obvious. All the documentation for the standard library, okay, looks quite nice, I think, and it's all pretty damn well written, and it is comprehensive as fuck. And what I love about this is when you're reading the standard library documentation, even if you don't have a particular idea of what you want to do with it at the moment, you can learn a lot about common pitfalls with this kind of thing in any language. Common pitfalls with I/O, or maybe, I'm reading into the same string from multiple places. That's kind of something we've talked about, right? I'm trying to put the stuff in the same variable, right? That's going to be harder in Rust. There's probably some method in here that makes it a little bit easier, I think. But the documentation for that method will describe clearly when it is okay to use, and it will be enforced by the compiler at compile time. Anyway, so let's read some input. Let's we need some string input. This is how you create an empty string that you can modify. Like I said, I can't get into these string types. And we'll most likely go over, but hopefully not too much over, and head out whenever you want. So I'm reading in, and I can turn it into an integer. Sometimes you do have to, like I said, write the type. So let's turn it into an integer. Let's see. Oh, okay, yeah. So this dot unwrap thing that I didn't show before has to do with how Rust handles errors. I didn't import this correctly. Very similar to a hash include in C. This use IO. Let's use instead of IO. Yeah, so here this unwrap is saying, I know that this is going to succeed. When might parsing input, when might trying to turn a string into a number fail? What? No, that's right. No numbers? Yeah, that would fail, right? It's probably also a good idea for it to fail if the string is actually like high. I'm gonna run this and I'm gonna say, x plus 1. No, you can't quite do that. You have to do this, which is just saying print out x plus 1. Probably still getting an error.
Would you do more commas for more variable prints?
What?
Would you add more commas for more variable prints?
Yes, it's a lot like printf in that you put, like, these are like the %b, %s sort of thing. You just put these pairs of braces and then you put
Can you use backslash to
whatever. What?
Can you use backslash with the curly braces?
Yeah, to actually print the curly braces? I haven't seen that. Let's see. No. I am sure you can print a literal curly brace somehow, but I'm not going to get into that right now. It probably works decently like that. What is going on with? Oh, is it because of this? No, that shouldn't be an error. Okay. Oh yeah, so it's waiting for some input. If I say 7, right. This is Rust is being persnickety, and computers are sometimes not your friend. I didn't just type in 7. I typed in 7 and then enter. You can't turn 7 followed by a new line character into an integer without saying that that's what you want. But I didn't say that that's what I wanted. This is a very conservative method. This only does what I told it to do. If this whole thing was just an integer, then put it there. So what I'm going to do is I'm going to assume that the user actually put in let's say the user actually put in, no. Will this work? Let's say the user typed a number, right? That's what we're trying to do. We're trying to print out the number plus 1 for our silly little program. I'm kind of going all over the place, but what this does is it takes a slice, much like in Python. It says, give me input, but with 1 fewer character, with input's length minus 1 length. And this is like an implicit 0. So it's like starting from 0, going to this point, Now I say 7, and it works, because it's just looking at the string with 7 in it. But if I say hi, right, it errors. And it errors, it says it panicked. That's how they talk about runtime errors. On line 9, column 55, which I think is the start of this unwrap. I don't know where my oh yeah, it is. Start of this unwrap, it says the error that we got was this parse int error. Unwrap is a weird word for this. That's because the way this works is parse returns what's called a result. It's a potential, it could have worked, right? It's the result of something that could have failed. And the value in it could be, just at whatever we were trying to produce. This is a generic. It's a lot like a template in C++ or a generic in a bunch of other languages like Java, C#, that sort of thing. So it's a result of this sort of thing, and it might have messed up. And that's also a generic parameter because there might be different ways you want to express that. I'm getting way off topic. I'm going to try to get at least this interesting thing. Okay, so I think the last interesting thing I said was that we can reuse memory, right, if we have these multiple scopes or if we called multiple variables. So let's say I'm trying to do this, right? Oh no, I did this for a reason. Let's say I'm trying to write this program, but I realize that this is kind of icky, right? Because what I actually want to do is I want to say, let's say I just, for whatever reason, want to put this print down here, right? Because that's kind of this is the main flow of my program. You know, I wanted to isolate maybe getting the input, doing this wacky stuff because I'm new to Rust and it's a little weird. And even when you're familiar with Rust, it's like, I have to think about this code. I want to isolate that. I want to be able to name variables whatever I want in there, and that doesn't impact anything else. Then I'm like, okay, what's the new value that I'm going to print? I'm going to say it's y, so it's x plus 1. And then I'm going to print y, right? What's the problem with this code? We can't refer to y because it's in this scope, right? We don't actually, you know, if we, okay, so we want to have declared it out here, right? So that we can refer to it. And that's fine. We can declare it out here. I'm not saying this is code you should write. I'm just saying this is, something one could imagine doing. We can declare it out here. Then, obviously, we can assign to it here. You'll note something interesting. This whole not modifiable by default thing should probably remind you of something like const or final in Java. If it reminds you of const, the thing with const is you have to assign to it when you declare it. You don't in Rust. This is fine. The scary thing, Rust says, is when values change, not when you don't know them when you declared it, right? Rust is nice about this. If I try to print y, that's not actually going to be, it's not going to print 0 or something. It's going to fail. It's going to say, okay, we've got macro errors, but this is the important bit. Y is possibly uninitialized, right? So the scary thing is that y can't change. Anyway, okay, so I can declare it out here, and then I can modify it, and we're good. It's a little, Rust doesn't like the fact that x is mutable because it never actually changes. That's just a warning, though. It would compile. I'll show that. This all works, right? Okay. Forget all this number stuff. Let's say I just want to take the user's name and then say hi to them, right? So I don't need to parse it. I just have this string. And then I'm going to print, I'm going to take that and I'm going to push a string onto the end of it. what am I going to do? I'm going to make a new string, right? Message, which we want to be like, hello, Sam, right? Hi. Then I'm going to say that this is, I think there's probably a nicer way of doing this, but I'm going to say this is a new string, and then I'm going to push hello onto it with a space. Then I'm going to push whatever the user typed, right, which is input. And I think this will all work. Oh, there's some shenanigans. Oh, yeah. Aresh, you were mentioning earlier, sometimes Rust tells you just what to do, right? Here it's telling us that I'm trying to push input into message. And I actually can't do this exactly like this for sort of complicated reasons, but I think should have found an example that would be more minimal. But the key thing is it's telling me, hey, you might want to actually be dealing with the address of input. You might actually want to be dealing with a reference to it. It literally just tells me, type that character here, and that'll fix the error in this case. Sometimes that causes other errors, but that means that your code's issue wasn't simple enough that could help. Okay, what's our other error? Oh, our other errors that I didn't save. Okay. Yeah, so y is not found in the scope, so yeah, let's print the message. Right? Uh-oh. Can't mutate it. Okay, let's make a mute. Okay, it's running. Hi. Hello, hi. Okay, that all works. This was a really bad example. I'm sorry, guys. Okay. I'm struggling to justify this code. Let's just say that for some reason what we're doing is we have this y that we don't know what it is yet, but it's just a reference to an integer. And when we end up printing it, we want to print that y. We're going to do our math, our parsing, input dot, we chop off the end. What? Oh, you can. Yeah, I'm not going to introduce that right now, but maybe it's nicer. Trim white space. Strip. No, I don't know what that's called. Sorry. Trim off at the end, and then parse that and store that into y. Let's be even sillier and say this is actually a pointer to y, right? That's what I wanted to say it was. Y, that's just an integer. So we have to modify it, right? But I should be able to do this once I remember to unwrap, like I was saying. Can't mutate immutable variable y, right? It needs to be mutable. Okay. Can't be dereferenced. Type I32, right. We need to be modifying the pointer. Okay. This all works. But now, there's a problem. I want to print pointer to y. Can anyone tell me what the problem might be? I'm trying to store a pointer to this y variable, and then I'm trying to put something in y through that pointer within the scope. It's because of what I'm putting there. I created this integer, and it is within this scope, right? At the end of this scope, we could reuse that same memory for something else, some other variable named, whatever. What Rust is telling me here is actually not what I was thinking. Right. Let's say y was originally 5, right? And then we just modify it. Or it was originally 0, right? We don't know what the user is going to put, so we say it's 0. Okay, now we get the error that I was actually maybe describing. No? Oh, yes. I said pointer to y. I called it that, but it's not actually a pointer to y. Okay. Fascinating. I screwed up in an interesting classic way, right? I actually wanted to say pointer to y should now point to x, right? Let's say pointer to y points to some variable x, which is, you don't have to do this, but to make it a little clearer, I think, points to some variable x in here, right? It's immutable. It points to it mutably as well. If it pointed to it like this, that's a problem because a mutable reference to an integer 32 is not the same as a reference to an integer 32. Those types aren't compatible. If we could just deal with mutable references as though they were, as though they were normal references. Normal meaning we can't modify through them, right? We could have an interesting situation where part of our code can modify this thing, and the other code expects it never to be modified. Someone writing something that deals with an immutable reference. This is different from, I think, how const works in C++. Someone writing code dealing with an immutable reference knows that that value will never change. Like the thing pointed to will never change. That's how they're thinking about their code. So those aren't compatible. Okay, so it's mutable. That's the point. We can't mutate this. Okay, yeah, sure. Okay, we changed it. Finally, I'm getting the error. Maybe. Cannot mutate immutable variable x, right? X does not live long enough. I'm sorry it took so long. X does not live long enough because it only lives for this scope. It actually only lives once we create it here. Now we can't use it out here. I think the better way to motivate this is something like, if we were doing this, processing in a function, I probably should have done that before. It, gets the input, gets the number. I'm gonna make it return this pointer to a 32, right? It's doing effectively the same thing, this same code. Now maybe it's a lot clearer. I need to copy some of this stuff too. I'm going to copy this, right? For some reason, this takes a reference to where to put its information. It's going to try to put something there. No, it doesn't need that. I'm sorry. Getting confused. But it takes a reference to this. Now we have that same issue eventually. Where is it? Let num equal get input. Calling functions is much the same as in C. Then I'm just going to try to print num. Whatever's behind it. You have ampermute x. Okay. We have a problem here. Okay. Yeah. This didn't go as I planned, unfortunately, as you can probably tell. But the key thing is we have to somehow start talking about how long this variable will last. That's what a lifetime specifier is. Because we can't, I don't know if you've written this code in C, you can't return a reference to something. Like if it were this function in C, it tries to return a reference to x after it created, that variable here. Yeah, C again, so it doesn't work so well in Rust. This isn't valid in C for exactly the same reason, but the compiler won't yell at me if I, create a new file, give it a horrible name for whatever reason. It'll yell at me here, but only as a warning. It does have red squiggles, but if I ran like gcc x.c, it says one error generated. What is this thing? Oh, yeah. This needs to return an integer pointer. Not that one. The linker doesn't like it because I haven't defined a main function, but let's just, say it doesn't actually do anything. We have this code. It runs just fine. It compiles just fine, and then when I run it, running the C code, it doesn't do anything. But it would be great if we could prevent this at compile time. Rust does, because if I say, okay, lifetimes, what do lifetimes look like in the Rust book, which is another really good resource that I'd recommend for Rust. The official book of the language. Okay, what's a lifetime look like? A lifetime is often written with this sort of like tick A syntax. It's a variable for how long this will last. If that doesn't make that much sense, that's totally fine. But it's this amount of time that it lasts. So I'm saying now that it'll last some amount of time, right? Trust me, this pointer will last enough time. This reference will last enough time. Now, I'm still getting errors because of my C. Now it says, actually, I don't know what that amount of time is, right? Because it could be too short. Okay, let's say that when we define get input, this is how you say, when you define get input, you decide how long it'll last. And then Rust is actually quite nice. It lets us call it without telling it exactly how long it lasts. In fact, I don't think you typically do. What we end up with here is a more interesting issue that I should have sped run to. We just can't return a value referencing a local variable x. I think it's really hard, and I'm going to wrap up pretty soon. I hope this hasn't been too much of a waste of your time. It's really hard to get through the complicated bit. But the thing that's neat is that Rust has this system that works generally. Even if your code is way more complicated than this, and you would be way more likely to write this sort of bug, it'll still prevent you from doing this. There's a lot more that I wanted to get to, and frankly, I want to, yeah, go ahead.
So in C, would you tempted to use malloc to put something on the heap
Yeah.
to get around this somehow?
Yeah, okay, sure. I'll show one last thing.
Yeah.
In C, maybe I was smart and I realized I can't return a pointer to the stack. I'm gonna malloc something, create something on the heap that I decide when it ends, right? It doesn't end when I return from this function. And I need to import all the relevant things. What is it?
Yeah.
Is it memory.h? No, it's not. Do you remember what it's?
No, that's why I asked. I'm not sure.
Yeah, sure.
Has to be good.
I think that's C++. Let's see. Malloc header. What is
Oh, I'm
malloc?
not the expert on malloc. C wasn't malloc either.
Instead of lib. Instead of lib. Standard library. Okay.
Yeah, makes sense.
Sure. So we've got that, and now we just return x. X is itself the pointer. We're fine here. How do you do that in Rust? Well, in Rust, this is I think the actual last thing I'll cover. I hope it's good. In Rust, what we do. Let's make this way simpler. Let's just return a pointer to 5. Screw that. We still have the same error. You can't return the value referencing a local variable y. In Rust, what we do is create this thing called a box. And a box owns its memory. What type is this? This is a box of I32. It's generic over the thing that's inside this box, right? A box, we talk about it semantically as having something inside of it, but at the core, at the actual machine code level, the box is a pointer to something. It is exactly the kind of pointer that we mean to create with this. It's on the heap, and I think the most important thing is it exists for a while. We're not saying this exists just for the function. We're saying this exists some amount of time. So what we can do now is we still can't actually return a pointer to the thing inside it. Okay, what I want to do is create something of type I32 that is, no, something of type ampermute I32 that is a pointer to the thing inside this box, right? I think what I could do with that is try to say y dot as reference, as ref, and yeah, that turns into a reference to I32. It turns into a reference to whatever was pointed to by this box. Okay. Now we have an issue. Mismatched type. Okay, we found a reference to integer. This is some silly things, but this y no, what is this? Oh, what is this? I'm not entirely sure what's going on.
But the good news is that it's not that easy to just do that work.
Yeah, the good news is that it's not
You
that
have
easy.
to
Oh, okay,
realize
right.
you're doing it.
As ref, not. This is the issue. As ref is. This is a weird thing in the syntax of the library. As ref means produces a immutable reference, right? Just an ampersand. You can't change things through it. As mute is going to create a reference through which you can change things. Okay, now I think we're having this error. You know, you can't change the actual pointer to y, and we still. I love this about Rust. We get even the same error message. Cannot return local something referencing local variable y. That's a little weird, though, right? I just said that y can last a while. What ownership means is basically just, this has a destructor. It frees, it's a malloc thing, and it's like we wrote this, you know? This is bad code, because the thing that we can do with this pointer afterwards is, I guess, like read it as like a number, like to figure out the address. We can't go through it. We can't dereference it, because we would be using freed memory. That's exactly what Rust is preventing us from doing. What we can do, because this box, the thing that it points to is going to last longer. It's a different type, meaning that you can treat it differently, right? That's why it's a different type. So we can actually return just y, this pointer to y itself. If, you know, I should have called this pointer to y, because really that's what it is. Now I can return that. I can, you know, print it even. It's unexciting, but prints 5. If all that went over your head, I'd be surprised if it didn't. This wasn't the kind of wonderful marketing exercise that I thought it would be. I hope you got something out of it. And unfortunately, you know, I'd love to talk with you more, maybe in groups right after this. Unfortunately, you know, now I have to ask you to sign this, scan this lovely QR code to register your attendance. This is a new thing, unfortunately. And you can probably figure this all out yourself, but is everyone scanned it?
No, not yet.
Yeah, sure.
Probably should put this on the pin though. I didn't even know we were.
Okay, yeah.
Will there be a recording of the
Yes.
I'll also be posting the slides as well with Discord.
Yeah. And I think that there are lots of things that I could do better. For the lug reading group, I will have more stuff, more plans, yes.
I would just say one thing: you can't actually do the attendance because it's we're past the time of the event. So
I'm
you don't
sorry,
even have to
guys.
worry about it.
Yeah, you don't have to worry about it. But you know, if you liked this, here's, you know, far too many QR codes. Hopefully you can zoom in. But I'm going to be doing a thing that I'll call the Lug Rust Reading Group, which is working through the basics of Rust. I think probably a little bit faster than just this, because this took too long for me, but certainly taking enough time. You won't have to do any reading, but I think it really would help to read. There's something on the Discord. I'll actually. Do you have those flyers, Eli, or those things? Now I can't remember if I did remotely the right thing. I sort of did. Okay, yeah. This QR code in the upper left, the one that was first visible, it's also on these sheets. It has more information on the reading group, and the idea is we'll be going through this book, whose title I love. I have no idea how long we'll get through it, but a lot of, you know, I think a classic way to learn all this memory stuff in any language is to write a linked list. It's particularly tricky in Rust, but I think that exposes you to the particularly tricky bits. And I think that the author here does an absolutely wonderful, far better than I did, job conveying exactly why you care about Rust, saving you from yourself in exactly the ways that it does. Also, I think that the code that she ends up writing is pretty well motivated. I'd also like to see, like, motivated as in you know why you're writing it. And it starts out pretty simple. We didn't go over all this syntax, but this is a lot like writing the definition of a class in C++ and writing some methods for it. We're defining a linked list, and we're saying, hey, you can push an item onto it. You know, I think it's wonderful. If you're interested, I'd recommend. I should be keeping that QR code up. Oops. If you're interested, I'd recommend reading maybe just through this. You know, she goes a little bit off topic here, but reading just that and seeing if that's sort of what you're interested in, and then I'd like to go through just the beginning of this sometime next week. I have not decided. This is all a little ad hoc, but the idea is, you know, you list your availability on these when to meet forms. You may have dealt with that before for this, and then there's another when to meet for this is coming up, you know, later. This is another topic that I was really excited about, and really am really excited about, teaching how the address sanitizer, which is a tool that can help make C and C++ a little bit less painful to program and a little bit easier to catch these kind of errors in that language, and catch those errors in unsafe Rust, which sometimes you have to use and works a lot like C and C++. The cool thing about this is I learned everything I'll be explaining in this session to pass my final interview at Apple. That whole thing was just going over how the address sanitizer works, which is described in a paper that I should create a link to and share that. Yes, also, if you've heard of the address sanitizer, it's probably because, sorry, 251?
Yeah.
Oh, neat. Probably because 251 here might have used it. 251 is a data structures course. Because it's, yeah, exactly, a sanity checker. I feel like that connects with the sort of thing I've been describing Rust is doing. So yeah, I'll leave these up. And if you want to talk to me, you know, I'll be around in just 5 minutes.